Hi everyone, welcome to our 19th Datagrok user meeting. We have 4 presentations today. The first one is for interactive predictive modeling that Kostya will show. You'll see how we can quickly train models right in the browser interactively, as opposed to the heavy modeling Konstantin showed last time. Then Maria will show us how to easily create calculated columns, now with full support for suggestions, autocompletions, and so on. Then David will follow up with showing us how to integrate Datagrok with the identifiers coming from the database so that your documents become more alive. And then David will also continue his talk with another topic related to databases and functions, which is the search integrated queries. That's a fascinating new development that I hope you will like. All right. With that, I'm passing the presentation to Konstantin.
Yeah, Andrew, just
you are host now.
yeah, I
By the way,
wanted
for
to ask
those
you.
who are new to our user group meetings, please feel free to ask questions at any time. And yeah, presenters will try to manage the time, but you don't have to wait for the end of the presentation to ask questions. Thanks, Kostya. Go ahead.
Yeah, so hi everyone. My name is Konstantin. I'm a software developer at Datagrok. And today I will be presenting you our new toolkit for interactive lightweight modeling. I guess I should, yeah, like that. As Andrew said, we will have a Q&A near the end, but feel free to ask questions as we go. If you have them, yeah, I'll be more than happy to answer. Let's start with the modeling ecosystem of Datagrok and the global picture. Because last time we showed you how heavy models can be used in Datagrok. That's models that are usually written for a specific problem by require expertise, require some coding in Python, for example, long training, and that get you the best quality. And for them, Datagrok provides integration with MLflow, and that's the way how we support this sort of models. But also now we will talk about the other side of this spectrum, I would say, the models that are really easy to train and the models that can provide you valuable insights in your data. So the most useful use case for them is usually exploratory data analysis. And our goal is to equip as many people with this toolkit as possible. So for us, it means that you don't need to write Python code for it. You don't need to prepare some sort of visualizations by yourself. You just have to do several clicks and get the results. And these results, they will be, as always with Datagrok, they will be interactive, they will be extremely visual, and they will be self-explanatory. So we want to give users context if they like it and provide them with powerful toolkit if they already have all the context necessary. And also what's important of it, is that a lot of decisions around the process can be made automatically, and we aim to do that. So let's jump straight into the demo, I think. Let me open my tab in browser. Here I have a dataset. It's a classical iris dataset. I'm sure a lot of you are familiar with it. We can see a visualization, a scatter plot on the right side, and the colors represent several species, and we can see that they are clearly divisible, and probably there might be some good classifier to write on top of this data. To create one, we will go to top menu, ML. Here we select models, and we want to train a model. Let's click on it. It will open us a new view, a predictive modeling view. That is the entry point to all our toolkit. Here, the two things we need to select is what to predict and based on which data. So for our case, if we want to build a classifier, we will try to predict species, and we will use some numerical features for this problem. When I select all the numerical features and click OK, let me wait a bit before doing it. What Datagrok will do afterwards is it will analyze what's the problem we are given, we gave it, what's the optimal model for this kind of problem, what's the optimal structure of a model for this problem. It will autofill some hyperparameters of this model. It will create a set of visualizations that's specific for this exact problem. It will give us some insights on the data we are working with. Didn't I miss anything? I guess yeah, that's the list. So yeah, let's just click OK and get all the results that almost instantaneously in the browser. So what do we see here is two screen split in two halves. In the left half, we already have seen the configuration of data, but below it, we have a configuration of a model. So we can see that, for example, for our use case, Datagrok selected an XGBoost model from EDA package. And below it, we have some hyperparameters and an overview of the current model. And on the right side of the screen, we see a set of visualizations for the current problem. Let's go over them quickly. So we see a scatter plot that gives us the idea of what the data is, what are the classes we've predicted. And well, this is a toy data set. We've managed to get all correct answers, so it's all true. We have a confusion matrix that will show us all the classes that we worked with. It will show us if we missed anything or if all of our guesses are correct. It will give us some insights and tips on the data we've worked with. So for example, in this case, we have the information that there is a high correlation between two columns. So maybe it might be a good idea to drop one of the columns from the feature list. We have some more visualizations of data were useful. So for example, yeah, we have some smart PC plot. Here it's always synced as with all Datagrok ecosystem. We have some metrics available for this problem. So for example, here we have an accuracy for the classification. And now let's look what can we do with this model. So let's go to the model configuration and, for example, tweak a bit the parameters because there are a lot of them. For most of the cases, we have some description of the parameters, so we can reduce the depth of the tree, for example, and we can reduce the number of iterations. And well, the model has changed. Accuracy dropped down a bit. Also, we can see that now we don't give all the correct predictions. So now we have two wrong predictions. They are both reflected in the corresponding widget, and also we have them in our confusion matrix. Yeah, so that's a way to interactively browse how your model operates under different constraints, under different hyperparameters. Let's try a different model, for example, but so we don't lose the current work that we've done, we will click on plus sign near the model, and then it's saved, and we can get back to it anytime we want.
Can I interrupt you for a sec?
Yeah, of course.
So the table with wrong predictions, the species and actual species. What are the species and what are the actual species?
That's a good question. Basically, this grid presents you the initial data. So, for example, for our case, we had 4 features that we used. But imagine if you have had a really wide data set, it will show you the whole information about mispredictions about it. So because we had a column for the species from the original data set, it just moved to this grid as well. Yeah, we can see the actual and predicted species in this grid. Yeah, they are labeled as last and second to last columns. You can consider them equal these columns, I would say.
Mm-hmm.
Okay, yeah.
Okay.
Yeah, thank you. Now let's try a different model. So for example, for this case, we have a softmax classifier from EDA package. Let's click on it. It will give us another model. We can see it's given us some different set of predictions. We have some wrong predictions. We also have a different set of misclassifications. And yeah, we can add it to our comparison tool as well. Now, if we decide that we like the XGBoost model more, we just click on this card, we get back to XGBoost model, and we can save it. So I guess let's just do it. Here we have some pre-filled name for the model, and yeah, we will just use it to save it. Now, this model that we just saved can be used with data that it's applicable to. So if one of your colleagues browse through the data and have some another sort of data set that this model can be applied to, he can just find this model under model section in the toolbox. Click on run prediction. It will have all the data auto-filled for him, and we can just click OK, and we get the predictions on the data. Let's, I guess, move on to another example of what our toolkit can do. So not only it has some visualizations and comparison tool for models, it also provides you with a set of insights, with a set of tips on what is better to do with your data, and gives you some idea of the next step in each situation. So I've opened another dataset. It's a cars dataset. And let's solve a regression problem. Let's predict the price for a given car. Yeah, and for the features, we will just select all the features that we have in our data. And the problem that I'm putting in this configuration of a prediction problem is that our dataset is not really big, and it has all the models in the dataset are unique. So the model column is a bad feature for any sort of a predictive problem, because we can just overtrain on it. And when I click on OK, we'll have some insights and tips that will give us information about our data. We will see that there are highly correlated columns, but also that there is a set of actions that we can do with a model column. We can either convert it from categorical to numerical through one-hot encoding, or we can also just discard it because it contains too many unique categories. Let's discard it. And now when I click on OK, we will get
just a quick comment.
Oh yeah.
So in that
Sure.
in that advice sort of list, it basically says what it observed, but it does not say what is suggested.
Oh yeah. Thank you for it's a good notice. We will update the text. So now the model that was selected for this dataset for this specific problem is an EDA PLS regression, and you can see that not only it gives us a different set of visualizations, so it shows us currently the residuals plot. It shows us how our price is correlated to predicted price, but also it shows us some statistics of the distribution. It shows us how the distributions of initial price and now predicted price, how they correlate with each other. And if I scroll a bit lower, we will also see some problem-specific, model-specific visualizations from EDA PLS regression. So it's basically a multivariate analysis in this context. So it's applicable. So we just give you this information as well. And we can understand that how the features, how they are impacting the price. We can see that there is a high diesel influence and like high influence of hatchback as well, just like in different with high magnitudes, I would say. Let's play a bit with parameters so we can improve number of components, because we can see currently that, for example, distributions are not really the same. When I click on the plus sign near components, model retrains, and now we get a better distribution. And we can see that R squared for our case is 0.9, so it's pretty high, and we can just save this model to use it in the future. And And yeah, I click OK, it saves. Let's try one more context, just so we show you all the possibilities that you explore with this toolkit. We can open our demog dataset, and here I will show you the power of our pre-processing in case of working with data, because this is a dataset that has missing values. It has some columns that are not integers, and it always requires some sort of pre-processing to work with datasets as such one. Let's try to predict sex of the subjects by some numerical features and some features that are categorical but have not that many values. So for example, let's use age column, let's use height, weight, let's use population and race. And now when I click on OK, I will get some information about this data as well. So we can start with the fact that we have missing values. And for us, the choice is either to ignore it or impute the missing data. Let's click on impute missing values, and we can just click on OK, we will get what we need. Afterwards, we still have some categorical columns, so we can one-hot encode them. And now when we one-hot encode them, we will get a model that that does the predictions for us. We can see this problem is much harder than the previous two. So yeah, for our classifier doesn't perform that well, but yeah, that's the life in real data. It's usually some problems will appear. For example, we can see that there is a high difference in sensitivity of models between training data and cross-validation. So we highlighted, we give you information that this might be a possible overfitting. For example, if you don't know what sensitivity is, you just hover over it. We have the description, and if you click on it, you will get also to the Wikipedia page, basically. What's also cool about the interactive, the interactivity of this toolkit that we have is not only you can play with model parameters, you can add some parameters on top of models. So, for example, here we have a binary classification problem. So we have two parameters that two classes that we are trying to distinguish. And so for us, we can click on predict probability instead of predict class, and we will turn our classification problem into a regression problem for a model, for a regression model. And it will allow us to get an autocompletion curve, for example, but not only that, but also to get some interactive way to adjust cutoffs of the model. So now, as it's a regression problem again, we can use PLS regression or linear regression or XGBoost supports regressions as well. And what we can do is we can, for example, improve the sensitivity of our classifier just by making a positive class higher. So for example, I will move it from 50 to 80%, and now it retrains. And the specificity went up. So now we can see that in like most of the target classes, we've classified them correctly, even though we can see that this is disbalanced predictions, that we have more mispredictions in general. And you can adjust your predictions based on a ROC curve as well. As usual, we highlight all the numbers that we think are worth noticing, that if you have some low values of your metrics, so for example, sensitivity is low here, so we show you that we consider it is low. We show you when some parameters are affected between trained data and cross-validation. And it basically allows you to make a better understanding of your data as you go with it. Just to recap what we've done today. So we've shown how we can train models right into the browser. how we can do the overall pipeline with like in an intellectual way where we don't have to code it. We have to select options that are that are needed in this case. That we will see the drawbacks of the model where we have some. We will see the interactive visualizations of that are related to this problem. And we hope it will give you a lot of insights about your data and will allow all the people in your company to use it, whether they know Python or not. So that's it for me. I'm more than happy to answer questions if you have some.
What happens when you click the save button in the top left corner?
Model is it shows you a window that you can fill or not fill with the information, and then the same model that you have here. So it's already pre-trained because we trained it in the browser. We just save its serialized it in a serialized format. It's saved persistently with the weights in the database.
So there is that global repository of models.
I can show you, I guess.
Not only the lightweight models that Kwesti is showing now, but also some sort of heavy models as well. So for instance, you can train models on Chemprop and using GPUs on a server. And these models would also appear here.
So for example, that's one of the models we've created today. It's it has the same sharing systems that all other Datagrok entities. So you can share it with your colleagues. You can share it with just chemists, for example. And it's usable in the datasets.
So how do you apply a previously trained model and saved model to a different dataset that has the same structure?
So we perform matching of the model and the dataset because our models are annotated. So our models
how exactly do you do that through the UI? What do you have to do?
Through the UI? Yeah, of course. I guess I've shown it with the iris, so I'll show it with cars now. Let's go to the cars test. So that's synthetic data. And for example, in Toolbox, you can go to models and it will show you the price that you can train the car with. You can predict the price of the car for this case. And when you click on run prediction, you will have a dialog that basically gives you the parameters of the model. In our case, we pre-fill all the parameters automatically based on their names, on their string similarities. And when you click on OK, we just run the same model in your browser and append the results as a new column.
Okay, looks good.
Thank you for your great presentation. I have one question. So, is all data used for training, or the split training and validation data set and build model during that training?
Yeah, that's a great question. Thank you for it. So currently what we do is we give you a representation of your model performance on your trained dataset, and we also give you a value of metrics for cross-validation. So for example, here we can see that, this is how model will perform on the dataset that you have. And if you try to work with it on some subsets of the data, that with 5 random splits of data frame, we got such values of average metrics.
Okay, thank you very much.
Yeah, it would probably be nice to introduce additional options for cross-validations and in general for validation of models. Which also reminds me of the next question I had. So what do we have in plans for that fantastic feature? I like it a lot. I mean, the lightweight modeling.
Yeah, so the next steps that we have is to make it even more accessible to users, basically. So there are some low-hanging fruits, of course. For example, as was suggested, we can introduce more and more like hints, more and more smart validators of data, smart rules for the data. But also what's important in here, what's the barrier, I would say, for some cases, is the step in we have a model that's selected automatically based on some sort of rules, and we can introduce new rules as well. But also there is a step where you configure a model, and currently model auto-configures sort of, but it's not that smart at the moment. So it's, I would say, the next step that will drastically improve the quality of a workflow is the step when we introduce smart hyperparameters of model, when it auto fills the parameters based on size of your data, for example. Because you've seen that the XGBoost classifier for the iris dataset, well, you can use it, of course, but when you use it, you better not give too much value to hyperparameters, because otherwise it will be overtrained. And also the next step after it is the step when the user doesn't have to do basically anything besides just telling what to do with what the data that's interesting. That's the step when we combine several models that are all really easy to train, when we autofill their hyperparameters, and we basically, based on our smart rules, predict the quality of the problem in general, like based on the best models, and you can select based hyperparameters, and you can select. So yeah, so it will be a one clicker. Yeah.
Great. I'm totally looking forward to it. Yeah. Thank you, Kostya. If there are no more questions.
Yes, thank you.
I'm passing the microphone to Maria, and Maria, you are
Yeah. Okay. Just a second. Well, okay, let's start with my part. My name is Maria, and I'm developer at Datagrok. And today I'm happy to share with you our new version of Add New Column dialog. As you may know, the calculated columns is a very powerful mechanism which allows you to create new columns based on any custom formula. And today I will show you how it can make your data analysis routine much more effective, much more intuitive, and I would say streamlined. But let's begin with the dialog. Open the Add New Column dialog in the first place. And for those of you who may not be familiar with the dialog, I would like to quickly go through its key features first. First of all, there are multiple things that can be entered as a formula. For instance, you can enter some very simple things, basic things like arithmetic actions. Also, we can see that the column values are also recognized. And of course, you can use formulas. And you can mix and combine all of this as you like. But what's more interesting here is that you can even mix different languages within just one formula. And I will show you on an example. Let's take a look at the functions. And here we have the body surface area script written in a JavaScript. Let's add it to the formula. And by the way, please note how easily I did that just using drag and drop. Let's fill in the parameters. Okay, we got the results, But we also have another script. It's a body mass script, and it's written in Python language. And let's combine those two scripts in just one formula. Let's do that. Let's add the BMI script, and let's fill in the parameters again. Okay. Now we will need to wait just a couple of seconds. That's because the second part of our formula is performing on the server side. I guess this might be the demo effect. Okay, I'm sorry, I will get to yeah, and now we see the results. Sorry, it took so long, but anyway, that's because the BMI Python script goes to the server and waits for it to get the answer. So we can see that the platform has recognized this mixture of languages and ran the formula seamlessly. So we can assume that the calculated columns is also quite an extensible feature. Among other things, useful things I wanted to mention is, for example, the column type order detection. Also, such things like fast function search and also column search, and the preview table. The preview table allows you to check your results immediately before you have added the column to your table. And this can be very convenient to assess whether you are getting the expected results before applying the formula to the whole dataset. Well, now, at this point, I'm going to show you on a simple example how just using add new column dialog, just one feature, you can solve rather complex tasks, and you can get from your initial data to the expected results just in a couple of clicks. Let's say we have a data set with a number of sequences in a FASTA format. And what we want to do is first, we want to convert them to Helm notation. After that, we want to drill down to atomic level structures for those sequences. And finally, we want to calculate some chemical properties on these atomic level structures. It sounds like a lot of actions, but all of this can be completed using just single add new column dialog, and as I mentioned, in a couple of clicks. So let's get back to add new column dialog and take a closer look. Here we have the list of columns from the dataset. And let's select the sequence column because this is our starting point. It's our sequences in FASTA format. I selected a column, and you can see that the function list on the right has been sorted. And we see the functions most relevant to our sequence column on top of the list. And those are functions which work with sequences. One of the key features that we introduced is that now the platform automatically suggests the most appropriate functions based on those columns you are working with at the moment. So you don't need to keep in mind which functions on the platform work with sequence semantic types or some other semantic types. And all you have to do here is to click on a column, and the platform will do the rest for you. So it will offer you the most relevant functions. And by the way, you can create your own functions and your own scripts, accepting your custom semantic types. And those functions will be also automatically included in this list, and they will be offered to you as you work with the corresponding columns. So now let's select the required functions for our case, it's convert sequence notation. And you saw how easily I did that just in one click using clicking on a plus sign. And the function appeared in the formula already pre-filled with the column name. And all we have to do is just fill in the rest of parameters. And by the way, we can hover over the function to find out more information about the parameters. And we see that we need to fill in the target notation and the separator. So let's do that. We now want to convert to Helm. And we have an empty separator because it's a faster format. So, and in less than a second, we got our results in the preview table. And we can zoom in to check out the results closely. And if we are satisfied with the results, if everything's okay, we just, by clicking OK button on the dialog, simply adding the column to our main dataset. But let's go further. Now we want to drill down to atomic level structures for our sequences. And we will also do that using the Add New Column dialog. Let's open it again. Now, just a second. I want to make it a little bit bigger. Okay, that's good. And now we are choosing the Helm column. Again, selecting the required function from the offered ones. And now it's sequenced to atomic. That's what we need. Fill in the rest of parameters. And in a second, we got our results. In the preview table. Yeah, and again, here we can zoom in. Let's do that. Just a second. I'm pretty sure that's something to do with my internet connection, so I'm sorry. Oh, okay, so we have our atomic level structures and we can check out, looks good. And now we are ready to add our results to the initial table by, again, clicking OK. Well, the final step is now that we can, we want to calculate some chemical properties for our structures, atomic level structures. And again, we are going to the Add New Column dialog. But now we're selecting the atomic column. And we see that the functions on top are different. That is because the atomic column is of different semantic type. Now it's molecule, not a sequence. And again, in this case, the platform did it all for us. So it found the appropriate functions and offered them for us. So let's select the required one. The get property would do perfectly. And let's calculate, for instance, the molecular weight. And again, I will make the dialog a little bit bigger so we can see the results. Everything's good, so we're finally adding the results to the dataset. And that's it. So just you can do everything in just one place, just as easy as that. And it's a very intuitive and a powerful approach, which can help you save a lot of your time. But what else? Besides the main feature, we also introduced a couple of very useful things which can help you work with your formulas. For instance, such things like formula validation. So in case you enter some errors, you will see the red error message under the text area. Also, we introduced different highlightings within the formula, and you already noticed that columns within the formulas are highlighted in blue and they are in bold font. So the columns are easily identifiable within your formula, and the formula itself becomes much more readable. And what is also very useful is that we introduced the auto-completion tooltips with the list of both core and package functions. So now you can just easily select from this list not to enter all these things manually. Well, I think that's basically it from my side. That is all I wanted to share with you today regarding the Add New Column dialog, and I really hope that you will enjoy this new version, and I'm pretty sure that it will help you spend less time on creating your complex formulas, but more time on focusing on your data. Of course, any feedback and any suggestions are very welcome, and now I'm happy to answer your questions. So thank you.
So once you have computed a column and persisted the results, there's no connection between the computed column and the original columns used in the formula, or is it?
You mean no, that of course there is a connection. If you used some column as a base column in a formula, so in case you change something in the initial data, then the columns will be recomputed.
Yeah, so go ahead and sketch a new molecular structure for the atomic. Let's see if it works.
Okay, let's do that.
Oh, wow, nice. How about sketching the helm?
Yeah, but that's kind of
reflect?
that kind of becomes pretty interesting here, because the atomic representation itself is the dependent value. So now it disagrees with the actual helm.
Yeah, because the base column for the helm is the sequence column. So in case we change the sequence, the helm will be changed too. But there is no connection between helm and the molecular weight here.
Let's now change the sequence and see if everything will be updated.
No, what I'm saying is that you have sort of interdependent columns in that table right now, right? So I would expect if they all depend on each other, the change in dependent values should not be allowed, because you start with the sequence, right? And then helm depends on the sequence, atomic representation depends on the sequence, and molecular weight depends on the sequence. So if you are allowed to explicitly modify any of the dependent columns, you may create like really confusing data sets. Because users may think that molecular weight is computed from the sequence, which is supposed to be, because you use sequence to compute helm, you use helm to compute the atomic representation, and then you use it to compute molecular weight. But now you've overridden the atomic representation, and then that row contains inconsistent data, essentially.
All right. Well, that's a good point, Dima.
Or at least a warning should be shown.
Yeah, we need to indicate somehow that it was edited, probably, but regarding disallowing editing, I would disagree with that. There could be many legitimate reasons for editing, and typically we give power to the users. But Maria, let's make this experiment. Edit the sequence and let's see if everything will be updated. I have not seen it live. Oh, nice. Was the structure and molecular weight updated too? I did not notice it.
I didn't notice also.
All right, there is some room for improvement.
So you see what actually happened in that row where you edited the atomic representation. I think it changed back, right? Or didn't?
In this case, it didn't, but it should have been changed. Yeah.
I'm sorry, it did.
So Dima Kovalov was working on that. So I guess he will fix the applications of formulas.
Frankly, I think it should be disallowed to edit dependent values, because it creates a really kind of it just opens all kinds of error-prone possibilities.
Well, but there are different ways. Sometimes you want to compute and keep it in sync, and sometimes you just want to compute and keep working on it. You might want to change it, even
in which case you have that you need to have an explicit option like persist value and forget about the formula connection in the table.
Yeah, we'll
because otherwise you can create really weird errors, in data sets. Because well, you understand the problem. I don't have to even explain.
Yeah, sure.
Yeah, I understand the problem. I just disagree with the conclusion, but we'll get it figured out so that you would see at least an indication that it's detached from the calculation. Yeah, there are different pathways users want to use. I do have another question though, Maria. In the convert notation, I absolutely love the functionality. Now that you can point to a column that contains some scientific data and see the applicable functions. But take a look at that example. When you converted formats, you did have to know that one of the supported formats is Helm, and you typed it by hand. But I think we can do it proactively and give user a choice. So help them with arguments.
Yeah, I think that's one of the next improvements we should implement is some hints for the users, which options can they enter or so on. There can be a lot of situations when user should know more information about the parameters he is entering. And the same thing actually with the molecular weight, because I also entered them by hand. So yeah, I agree. We need to help users here and to provide some options for sure.
Yeah, because internally we do have it. For many options, we have choices annotated on a property level. So we just need to work with that information. Either that or a function that would generate the user interface for specifying the value. So all of that we have in the platform. So yeah, looking forward to the next iteration here too. Great, thanks for your presentation, Maria.
Thank you.
David, you are on the stage.
Hey, great. Hi, everyone. Okay, just give me 1 second. Okay, you see my screen. Okay. Hello, everyone. My name is David. I am a scientific application developer at Datagrok. And today I'm going to be showing you 2 features, and I'm going to start with the Database Explorer feature that we have added. So first, let's start by defining what we are trying to solve here. Now, many of you are probably dealing with very, very large databases with thousands of tables and so on. And most of the time, what you want to do is to just get some data for some compound or some identifier. And then what you mostly do is send it to someone else, share it via something like Microsoft Excel. And the moment you do that, all the connections to this data is lost. And whenever some other person wants to retrieve some other data about this compound or this entity, what they have to do is to write some other complex SQL queries with complex joins and so on. This in a sort is kind of a bottleneck there. And in Datagrok, we like to do things much, much simpler. So for this, we did this database explorer feature. And let's explore it, what it can do on the example of the Chembl. So as you know, Chembl has millions of compounds and some hundreds of tables, which contain some different sorts of information about those compounds. And each of the compound in the Chembl is identified with this special pattern, which is very conveniently starting with Chembl and then followed by some numbers. So what I can do with this feature is very simply tell Datagrok to recognize this sort of pattern pretty much everywhere. So Chembl followed by some numbers, and then it automatically picks up the table it needs to go to retrieve the information, and also every single information that's going to be linking to this entity will be automatically picked up. So let's see that in action. So here, where I am at right now, is the landing page of Datagrok, and up top you have the search everywhere bar, which is actually very, very powerful. And here, what I can do is just paste in some Chembl identifiers, and automatically I'm going to be shown some of the cards, including the molecular structure and some of the other information about those compounds. Now, this is still a limited amount of information. So what if I want to do some more and get some more information about some of the compounds? So I can click on any of those, and now it's going to be moved to the context panel on the right, as you can see. And the top information is going to be the same that is on the card. But what's more interesting is a bit below. So below, I'm going to see every single table and every single information that is linking to this compound. So including some activity records, biotherapeutics, drug mechanisms and drug indications, so on and so on. So for example, let's inspect the activities. And I can see that I'm going to be shown here 10, but I'm also shown that there are about 2,400 records in there. I can open up any of the activity records, and I'm going to see the whole information about this particular record. Now, I'm also going to see that some of the things here are highlighted blue. And these are, again, very quite automatically picked up that they are linking to some other information, to some other table. So for example, this assay ID, I can see that it's blue. I can hover over it, and I'm going to be shown the information in the tooltip, what this assay information contains. I can click on it, and now this becomes the current thing in my context panel. I can see all the detailed information, including some of the other links highlighted in the blue, like TID and so on. And I'm also going to be shown a deeper view of some other tables that are linking to this assay IDs. For example, there are 2 activities that are linking to this assay ID, and so on. Now, as I said, I'm only shown 10 here, but what if I want to inspect all of them? So what I can do is just right-click here, click on Add All Associated, and I'm going to be taken to a new table view where I'm going to see all 2,400 records of this particular compound and its related activities. And if I want to go back, I can just click on all registration number, which is similarly recognized throughout Datagrok, and I'm going to be shown the same sort of information. I can drill down to any of the tables, compound properties, for example, and it's automatically retrieved, and so on and so on. So are there any questions up until now?
Yeah, as usual, I have a question, and unfortunately, I will have to bail out because I have a meeting starting in 5 minutes. From end user perspective, when the user does a search everywhere and then comes across this kind of data, how would user know from where the data comes and say which version of the Chembl database is being used currently? Because it may actually be extremely important that they update the database all the time. Usually release a new version twice a year.
Yes, well, this This mechanism is super simple to configure, but it still needs to be registered in the Datagrok. So we need to tell Datagrok that, okay, recognize this sort of numbers and start from this table and start from this database. So there has to be someone that kind of does that first time. So since you mentioned it, let me show you how the configuration looks like.
No, I mean,
this is
say I'm one of the end users, like I'm a scientist, right? So I did this search, and I was shown this particular view of the data, right? And then my colleague asks me, where the hell from which version of the Chembl database did you extract that data which you're currently showing me? It was at version 17, version 23, version 20, version 30. And when was it published? Because data in Chembl database changes all the time, with each release.
Well, yes, I do agree
with that.
But
Datagrok is connected to a Chembl database,
to tell exactly where this information comes from. How do I do that?
Yeah, so we can probably show the on top of the database where it's coming from. I don't think that's a big issue though, Dima.
I would disagree because
I mean, it's
Chembl
right
changes,
there
and if you connect some
below.
other database, the data also changes all the time. New data is added, and old data gets edited quite often or corrected. And they say, okay, you had that compound, right? And I know that in recent literature, that compound has been tested against those targets, and there's PubChem data about it, and or Chembl data about it, but I don't see it here. Why? And I was like, that's because we're using the Chembl database, which is like 2 years old. So at least the user should be able to see the data connection properties on the name and the version of the database from which the data is extracted.
Okay, fair enough.
Yeah, unfortunately, I have to bail out now, but I'll listen to the rest of the recording afterwards.
Yeah, thank you.
All right, thanks. Looks pretty good, though.
Yeah, thank you. Yeah, and as I said, it's super configurable very easily, and you can use it for any of your proprietary databases, not only Chembl. I'm just showing this on Chembl. All right, are there any other questions, or should I move on? Right. So the next thing, as I said, that once you do this configuration and you tell Datagrok that, okay, these sorts of patterns are the Chembl identifiers, Datagrok starts to search, identify them pretty much everywhere. And this includes also table views. So if I go over here, I have a table view with some molecules and some Chembl targets. And you can see that some of the columns contain the Chembl IDs, and they are identified, highlighted blue, suggesting that there is much more to the identifier than just some words. So here, similarly, I can click on them, and exactly the same sort of information is going to be pulled up on my context panel, and I can do exactly the same thing. This, again, happens without any specific annotation. If you have those numbers in any of the data sets, they will be automatically recognized. And what's even cooler is that it's not required that they are separate, so they can be a part of a text. So for example, if I just add some text at the beginning and at the end, you can see that Datagrok doesn't care about it, and it still identifies the Chembl number in the middle. And similarly, I can hover over it, and the same sort of information will be readily available for me. Okay, and you would see that, as I said, this is super configurable. You can do it for any of your own proprietary databases, and the configuration is actually quite minimal. This a simple JSON file is pretty much all that is required to make this work. And as long as you have a connection on Datagrok to your relational database, it can automatically be set up there, and pretty much you will never have to share your data with Excel with losing the connections and so on. You just tell your colleague that this is the identifier, and they just paste it in Datagrok. They see all the information they would ever need, and this way it's actually not static as well. So the data will be always live. And not only for compounds, this system can be very useful for other modalities. Like for example, for chemists, they can use it for the compound registration systems, yes. But for other modalities, like for example, lawyers can use it to get the information about their documents in the database, where they also might have tons and tons of different tables, and they have some identifiers for their documents. And from those identifiers, they could super simply pull up the every single information that is relating those documents or whatever there might be.
I have a question, David. So when you clicked on Chembl identifier, you see dozens of database tables to the right. How does it work? Is it sort of configuration that you should add? Or
no. So as I said, everything happens automatically, and the relational databases pretty much always contain all the information. So when you have tons and tons of tables, the tables within the database contain information which columns are linking to which other columns. So this information is automatically picked up in Datagrok. You do not have to do any sort of configuration. You just have a single entry point to the table where you start from. That's it. That is residing in the configuration file that I showed, and then the rest happens automatically.
Okay, yeah. So the rest is magic. You just point.
Yeah.
Probably a regular expression to a database column,
Exactly.
and that gives you the ability to navigate all your database. And it will understand all the IDs in all sorts of documents now and tables.
Yes, exactly. And as we like to say it, this feature allows you to better grok your data.
Yeah.
Right. Okay. Are there any other questions? Okay. Then I might move on to my next thing that I want to present, which is the Powersearch. As I said, the search everywhere bar in Datagrok is super powerful. And not only it allows you to search for some registered identifiers, but it also allows you to register some certain sentence patterns in a regular text way. And then if you have, for example, some query or something that you search for quite regularly, you can super simply register it inside of Datagrok, as everything is a function. A search is a special type of function, and you can have multiple search functions which are reacting to a specific pattern, and then the information related to this search will be also automatically pulled up in the search everywhere bar. So let me demonstrate on also a couple of examples from Chembl. So I went on and super simply registered a patterns, for example, for the bioactivity for bacterial targets from Chembl, and I can paste this. Oops, sorry, my bad. I can just paste it in the search everywhere bar, and I can see that the bioactivity for bacterial targets for the organism Shigella has been pulled up immediately, along with a default layout. So what I can do here also is I can go to the header of this pane, and I can add this as a table view, and it's a regular Datagrok table. But again, I can change this to a different sort of organism. For example, I think it should be, okay, let's try something like this. So it also accepts some SQL expressions. So this might pull up something something similar to E. coli, if but I'm guessing that there are a bunch of things that are relating the coli. Okay, but meanwhile that is loading, let me show you some other queries. So for example, I can also retrieve some pharmacokinetic information about some drugs. So for example, this levofloxacin data and all the information regarding the pharmacokinetic data for this drug will be pulled up. But again, if I put in a different drug, this will be recognized, and information for the different drug will be pulled up. And similarly, I can get also the activity details for some Chembl target, and I know, let's see some different identifier. Okay, well, this one was not found then, I'm guessing. Okay, yeah, it was found. Okay, so there was no Chembl compound under this identifier because this is a target identifier. But you can see that this feature will also very simplify the process if you do a similar sort of queries, but for different sorts of stuff inside of Datagrok. You do not need to run any query. You do not need to write any SQL pretty much. You can just very simply register those sorts of human readable text format patterns, and then inside of search everywhere bar, just type in whatever you want, and the information, all you need is going to be pulled up here. Okay, so are there any questions up until now?
Of course. How do you do it? And that looks like magic, but how do I do it myself?
Sure. So basically, as I said in the beginning, everything inside of Datagrok is a function, and we have a special type of functions, or rather a annotation for a function for a search functions. And pretty much everything, a script, a package function, or some Python thing can be just annotated with a tag search. And this tells Datagrok that this is a potential search function. And what it does whenever you type something in the search everywhere bar is calls this function and asks it, okay, are you applicable for this particular query? And if so, give me something to display. Basically, that is what happens under the hood. But if you want to add your own, again, you can do it in the package. You can do it in JavaScript, in Python inside of Datagrok. You just write a function and give it a tag of search.
So maybe just show us the query that you've used for showing these dashboards.
Of course.
How easy is it to do? And it's not only a database query, right? It's also has some visual layout applied.
Yes. So, okay, do you want to see the code? You mean, right?
It's, I mean, isn't it within the Datagrok as part of the query?
No, it's in the Chembl package. The Chembl ones are in the Chembl package. Yeah. Because it's better to write it in JavaScript, because you need to parse the thing as well and return nothing if it doesn't match your particular pattern as well. But
yeah, we need to make it available in Datagrok as just meta information on a function level.
Yes,
yeah,
definitely.
So this one was one-off, but we really need to provide that no code, and I think we already have it. It's just not this particular example. No code way to build your visual layouts and associate with the query.
Yes, but otherwise, again, as I said, you can just annotate the function with a tag of search, and that's going to be it. Right. And one other thing that I also wanted to show you is that we have done this similar database exploration configuration for our own Datagrok database that kind of holds all the information about everything that's going on inside of the platform. Let me show it here. So for example, again, super simple configuration. I think a couple of lines of JSON for the Datagrok schema, and I can just type in some user information. So for example, for myself, and it's going to pull up the information alongside with my image. And if I open up the context panel, I can see there are tons and tons of tables that are linking to the information of myself. For example, I can go into the reports, and I can see that there are some reports that I have created, and even it automatically picks up that the column inside the Jira ticket is a link. It kind of swaps it out with a Datagrok identifier. If I click on it, it opens up the Jira link, and so on. So it's basically everything happening automatically. And if, again, you want to set it up for yourself, it's super easy to do. And we will provide the instruction, very simple instructions to do that as well. And also, similarly, I was able to super simply create a search query for Datagrok database as well. And this one is, for example, to see how many new users were in last something weeks or days. So for example, I can see that I can search for new users last month. So there is only one here, but I can also do last 4 months.
And that's our development database, not the public. So that's why new users.
Yeah. This is the development database indeed. But I can do a bunch of different patterns, and it's pretty much with this system, you can register as many patterns as you like. So like if I want last 12 months, again, a bunch more. I can do last 3 years. Okay. Not that many actually on our development database, but you can see that this is super powerful, super extensible, and pretty much whatever you can imagine, you can do it here. And for the end users, you're gonna make their lives much better in this way, that they don't have to execute anything, write anything or something. They just write the text in a human readable format and get the information, whatever they need.
Yeah, this is fascinating. So for, say, for a pharmaceutical company that has its own proprietary database, you only need to connect the database to Datagrok, and then, well, you point your identifiers to the database column, and that's it. And you provide a couple of, and you provide these search functions. So essentially, you just map the sentence to parameters, and this is it. Nice.
And it's super extensible. So this minimal configuration that I showed, it basically works out of the box. So you don't need to think about configuring or anything, but you can do it, and you can configure everything. So you can configure external connections. So you can say that, okay, this column inside of this table is actually pointing to some completely other database. And whenever you see it, I want to query it there and go outside the box, let's just say. And you can use custom things to render. You can, well, images and molecules are going to be working out of the box, but if you have something else, you can pretty much configure everything that you can imagine.
Oh, this is great.
Okay. So any questions? Okay, cool. Then thank you. I guess that's it from my side.
Okay, thank you, David. Yeah, that was our last presentation for today. I want to thank everyone who participated in the making of the presentations, making of the release, and also to our users who stopped by for this meeting. Our next user group meeting will happen in about 3 months. We will send the agenda soon, and this one will be on YouTube soon. So thanks everyone, and have a great day.
Bye, everyone.
Thank you. Bye.
Bye, everyone.